will start. Are you able to hear us remotely? Can someone say if the remote people are hearing us? No. Yeah, but are they able to hear? Let me check the chat. Clear on remote. Cool. Thank you, Jeff. Okay, let's get started. So it seems that we are in competition with AI meetings, so we have a very crowded room here. And thank you everybody for joining this BESS session in China. So we will start with our usual chair status. Oh, so I'm going too fast. So we are on Wednesday. You should be already aware about this not well. If you are not, please read it. So you need to comply with the IETF policy, try to keep polite between each other when you are speaking and discussing. You should also be aware about all these meeting tips. So you need to join Meeteco even if you are local, so you can join the queue. So we have just a single queue to manage. And for remote participants, yeah, just unmute yourself when we allow you to speak. So Monkabana, our secretary, which is just on my left side, will help with the notes. But if anyone else wants to complete and help with the notes, feel free to do. One important information, so there is a new review directorate which has been set up recently, which is a BGP directorate, whose purpose is really to help in providing good reviews on BGP related topics, especially preventing us to break via BGP protocol, for instance. So we will leverage more and more this directorate now to get early reviews, exactly as what we are doing today with the routing directorate or the GenArt. So of course it will be a kind of mandatory step for us, at least for the relevant draft, before moving the draft to working group last call. So we already sent a few documents to them, and we are expecting now some reviews to progress this document. So this is our agenda. I think we have a good time for a discussion. We have a good amount of buffer. It's not a full session today. So status update, there was no new RFC compared to the last IETF. We have few documents in the RFC editor queue. So in fact, the unequal cost load balancing has just recently moved to RFC editor. I think it was yesterday. So now we have 3 documents in the RFC editor queue. And I think this SD1 usage document still have issues, and it's not progressing yet. We have one document in working group last call, which is the eBGP DMZ, which is a joint working group last call with IDR, and Jeff Ass is shepherding this document. So I already received some comments because I'm one of the co-authors, so I'm planning to update the document accordingly post IETF. We have also a couple of documents in a Shepherd review. So there is still this Kubernetes draft, very, very, very old draft about this VPLS multi-homing. And I think Matthew is just ready to click on the button and send it to IESG now. The EVPN control plane for Geneve. So now the statute is experimental and IESG is really requesting to, I would say, justify the status and providing, I would say, more information about what kind of experiment the authors want to do or are already done and so on. So the authors needs to help in addressing this before we can actually move forward. The seamless multicast interoperability, so EVPN to MVPN, so it's under the responsibility of Monkamana, who has to provide the Shepherd review. And on the EVPN BFD, I think Matthew is waiting for the response on the implementation poll. Okay, go back to eBGP DMZ. So I see a comment from Jeff that we got very few comments and he's waiting for more. Do you want to say something else, Jeff, on the eBGP DMZ?
Not specifically. We have the COLAS call going on in both BESS and IDR on the DMZ draft in BESS, and then the RFC 4360 BIS document that's related in IDR. We have received very little comment for both documents. Both do go together, so we would like to get comments on both of them as much as possible. That said, they're known to be well deployed, and the documents are very stable, but we'd like to actually get feedback to let us know that we can indeed send this document forward.
Okay, thank you. So we have a couple of documents that are still ready for working group last call. If you see that there was a document that you think was ready for working group last call and which is not in the list, feel free to say it to us so we can update our queue. Honestly, we were not super efficient over the past month progressing these documents. So we will do our due diligence really soon to progress this, especially the 7432 BIS, because one of the milestones was to send it to IESG by March, which is giving us just 12 days. So likely we will be a bit late, I think. No, don't worry. We have adopted 3 documents as working group documents. So the first one was the mobile user plane SAFI, which has been sent, by the way, to the BGP Directorate already to get some early review. We have this EVPN multi-homing for layer 3 services, as well as this UMR mobility. And I think we have a presentation today on the UMR mobility. And this is our queue for working group adoption. Again, if you requested some adoption to us and the draft is not listed there, just let us know so we can actually fix it. So these are our milestones. So yeah, likely we are late on a couple of things, probably many things. So 7432 BIS is likely one that we should progress really, really soon. EVP and BFD, as fast as the offers are replying, we should also be able to move it to IESG. VPLS multi-homing is ready to go. So yeah, an unequal cost load balancing, it's now in RFC editor. So I think this milestone is okay. EVP and Yang, not EVP and Yang, but all the Yang related documents, we still don't see any real traction to progress them. At least we haven't heard anything from authors or any contributors, so this work is likely still not really progressing. Okay, so we are good with the update. Jeff, you want to say something?
Yes, not presuming to speak on behalf of the authors, but Thomas Graf and company have a document for streaming telemetry for BGP related things. They are making use of Yang to do so. They will probably be coming to BESS to straighten out the dependencies that are needed to do so. So I will paste into the chat the draft that people should be looking for, but this may cause you to accelerate this work to completion.
Right. Would you be able to contribute? Because, yeah, we need people to actually move this work forward.
As I mentioned at the IDR session, I'm somewhat weary from the multiple years worth of work I've given to the BGP Yang. I am willing to offer advice and help review, but we would be looking for a primary editor in that case.
Okay. Okay, so let's move to our agenda. I think, Krishna, you are probably the first one. Yeah, hold on a second. I'm trying to. All slots for the requested media are ready. How do I fit? I'm not able to share anymore. All slots for the requested media are already taken. Are you able to share on your side? You don't have the permissions? Are you running the full client or? Yeah, sorry, I have an issue sharing the slides. Mm-hmm. Can you try to connect? Can you try on your side? Yeah, when I click on sharing slide, it says all the slots for the requested media are already taken. Okay. Okay, I will try to disconnect and reconnect. You need to cancel before trying. Where do I? Where do I do that, Jeff? This cancel.
So if you go to the same icon that you used to select sharing something, you should be able to click that a second time. If not, you can look at the user configuration, and you should be able to see something that lets you uncheck it. If you uncheck slides clicker, that's probably what you need.
Oh, yeah. Cool. Thank you.
Okay. Hi, I'm Krishna Swami from Cisco. I will be presenting 3 drafts. 2 of them are related to the max scaling, and one of them is an informational draft which specifies multiple interoperable modes. So we'll start with the UMR. Okay, so a quick recap on what is UMR, right? So unknown MAC route, it's defined in RFC 9014 to improve the MAC address scalability on the PEs, right? So the basic idea of this is, you know, the local PEs will have only information about the MACs which are within that DC, and all the remote DC MACs are present on the gateway. So while this improves the MAC scale significantly, but it disrupts the EVPN MAC mobility procedures. So this draft addresses the MAC mobility handling in this when using the UMR. So even though initially this draft started as to address the mobility aspect of it, but in the previous version we made a significant progress thanks to Ore and Alex. So we have added uh, different functionalities to handle if it is a layer 2 only mode or a L3 mode or an IRB, and some of the EVPN use cases related to the R1ND proxy and also how to detect the silent host, right? So those things is getting already added there. Okay. So okay. So we have also captured what are the requirements in order to support this UMR mobility and other aspects. So one thing is it could be we all the PEs which are part of this UMR domain, they need to support this particular draft. What if we have some PEs which are not supporting, then we have to logically partition this into an UMR capable and UMR not capable. Okay, so then the MAC mobility between the UMRs and non-UMRs, so we need to still support it. It's not just limited to the UMR. And yeah, and of course this is an optional okay. So just do a quick recap into what is the issue with the MAC mobility, right? The MAC mobility, in order for MAC mobility to happen, the MAC has to be present on the PE where the MAC moves. So that's how the mobility sequence number is getting incremented. But with UMR, the local PEs will not have the information about the remote DC MAC, and whenever a host moves from a remote DC to the local DC, so it will be treated as a completely newly learned MAC. Okay, so this is something which is going to break the existing EVPN MAC mobility procedures. So the proposed solution is move the MAC mobility procedures with the UMR from the PEs to the gateways, and maintain two mobility counters. One is an intra DC and the other one is an inter DC. And whenever the mobility happens within the local DC, increment the intra DC counter, and between the DCs, then it will be an inter DC. Okay. So yes, on top of it, as I mentioned, right, we have added a few more details there. So what we want from today's presentation is, this is being supported by multiple vendors, and we authors believe that we have captured the enough information, and it is stable, and it is from last few years. So we would like to request a working group last call for this. Okay.
Any question? Okay, I think you are also the next one. Let me change the slides.
Yes, the EVPN interoperability modes. So this particular draft has been adopted as a working group draft from last, close to 5 years now, right? So, and we wanted to request for a working group last call. So we thought, just give you a quick recap on what it is and and later request for the working group last call. So this is an informational draft, right? So this is not going to change any EVPN signaling. So there are different, functional modes defined in different RFCs. 7432 defines this service interface, then 9135 defines IRB mode, and 9136 about the core interface IRB modes. Okay, so since there are different the functions, so when we have a set of devices which are participating one particular functional mode, how 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 do they interop with each other, right? So that's entirely the procedure is being defined in this particular draft. So okay. So not all interface are the service types, right? So which are not interoperable. So but we wanted to just give a quick recap here. So I'm not going over the details about the interoperability procedures because the draft is already been adopted in for more than 5 years from now. So yes, in the service types in 7432 defines a VLAN based, VLAN bundle, and VLAN aware bundle, right? So these are the different interoperable types, and the draft clearly defines that what are the set of procedures that needs to be implemented on a PE device in order for it to the interop, and also defines about asymmetric and symmetric IRB and IRB connectivity types, which are like interfaceless, interface full numbered, and unnumbered ones. So with the latest version, right? So we have cleaned up all the sections, then fixed all the RFC style format, and I added security considerations and IANA considerations. Yeah, since this has been there from quite some time, and we wanted to ask for a working group last call.
Thank you. Any comment on this one from the group? No? Okay. Next draft.
Yeah. So this draft talks about EVPN L3 optimized IRB. So I want to give a quick recap on what it is. So this is also tries to solve the problem of the MAC scale, right? So if a device is participating in an IRB, then the MAC learning is mandatory when the subnets are stretched. So we have to exchange the MAC routes so such that the subnets could be stretched. So what happens is the CE device is just going to bridge it, and when it delivers it to the PE, then it has to do the MAC lookup and forward it, right? So what we have seen, right, some of the operators, right, so they have devices which are of the max scale size is much limited compared to the IP routing scale. Then the other thing is some of them are also interested with these layer 3 only policies, and they need L3 only kind of features. So the main objective of this is, how do we reduce the max scale, right? And once we reduce the max scale, and if you are doing a routing, then we still wanted to preserve the mobility aspect of it, okay? And of course, use the L3 model for the forwarding. So that's the this draft is talks about, okay? Now, since the routing is getting done here, of course, you will have a TTL decrement and few other things that needs to be considered, and there is a caveat section which has been added in the draft, and we request the working group members to go and read that. So here we just wanted to talk about what are the three different local proxy ARP and ND. Right, so there are three ways that we could provision. So when we enable a local proxy and ARP, so we could respond unconditionally, even though that particular host is not present with the the router's the MAC address, or it could do a conditional, and another option could be conditional ARP replay whenever you see that the host is present. The third one is that something what we have added in the previous version, the 03 version of the draft, where can we make use of the host discovery via the BGP control plane. So this is something we have not added the further details, but for the first two things, we have clearly defined all the procedures. But the third one is something we have to define. So that is still some work to do. So what is the option A, right? So unconditional ARP replay for a neighbors, right? So, let's say in this case, the host 1 is trying to reach to the host 2. So it's going to send an ARP request. Then the P1 is where the host 1 is attached. It's going to send the response back. And of course, it learns the MAC and IP, and it's going to advertise this type 2 route to all the Ps. And when the data packet comes, right? So at that point of time, it is going to initiate the glean process, and it is going to send the ARP request. And once the ARP response comes from the host 2, I've not captured that in this diagram, right? But it is there in the draft because since this is just a recap. So then the host 2 will be learned on PE3. Then the type 2 advertisement will make sure that PE1 also knows that where the host 2 is. Then the respective the packets will be flowed towards the PE3. So this is the unconditional ARP reply. So in this case, we are waiting for the data packet to learn the particular the host. Okay. Then this one is a conditional ARP replay, right? So this also works in a similar fashion, right? So if the host is present, then only the response will go with the router MAC in the ARP response. But if it is not present, at the same time, what it can also do it is, it could initiate an ARP, a clean entry, and it could initiate an ARP request and learn the host too, right? And whenever the host is learned, then at that point of time, it can send the response back. So that's the option B. The third option is, as you guys see in the earlier two, even though we are not exchanging the MAC, we are not doing the MAC forwarding, right? It's always an IP lookup, but still you have to bring up the layer 2 domain in the entire fabric. Let's say if the user don't wanted to do that, right? So then in that particular case, so we are proposing a new host discovery route. We have not defined fully the mechanism in the draft, but it will be coming in the future the versions. So the main idea is, instead of sending the glean, the ARP, and sending the ARP request itself, rather you send this the host discovery route, so that way the response comes from the host too. So that's the main idea of this. Okay. So yeah, some interoperability aspect. What happens, some devices supports this host route and some doesn't. So we don't want to do too much complicated about optional capability and understand that, whether there is a support or not, because as you guys know, it's a hop by hop protocol, right? BGP VPN. So in that case, yeah, the user needs to enable both the options, right? One is the flooding in the flooding the ARP, then also sending the host discovery, then the whichever is the PE which supports this host, it should make sure that don't respond it back with the ARP request 2 times. So that's the only thing. So with this, we feel that this document is quite stable. And of course, we wanted to add that option C details, and we would request a working group adoption, and also open to any working group members wanted to provide any suggestions.
Thank you. Any comment? Okay. Thank you, Krishna.
Thanks.
Jorge, you are the next one.
Morning, everyone. This is Jorge Rabadan, Nokia. This draft, it's ready for working group last call. So, but before that, we wanted to give you the last updates that we made. So we added some changes in, well, 3 aspects. First of all, some updates to address Jeff's comments. We clarified which EVPN routes must not include the DPath, and we added an operational considerations section describing the impact of using DPath when not all the PEs support this specification. The other thing, the EVPN, IPVPN interworking draft was recently approved by the IESG. And as part of the review by the IESG, we made some changes and we adapted the terminology. And those terms are actually applicable to this draft because it's using the DPath that was originally described in the EVPN, IPVPN interworking draft. An example of that is prior to this version, we were using the term redistribute on the gateway PEs to indicate when a route was being imported and re-exported. Now we call that reoriginate. We also clarified that DPath advertisement is disabled by default and must be explicitly enabled. And the other thing that is important is we updated the error handling section for it. With that, basically, yeah, we've presented this multiple times. We addressed all the feedback. There are multiple implementations in the field, so it's really ready for a working group last call.
Okay, any comment? So we have sent this one to the BGP Directorate as well to get some review from them.
Okay, sounds good.
So we will wait for the feedback, and if the feedback is fine, we will move forward to the next step.
Sounds good. Thank you. Okay, this is the EVPN interdomain option B draft. We've presented this also several times, but in this revision 8, there are important changes. So the draft basically goes through all the procedures required to support interdomain option B, meaning inter-AS option B or next-up self-RR scenarios. It goes through all the different procedures and addresses some of the issues that we have. One of the issues is the lack of identification in the 80 per ES route in EVPN. So this route doesn't have like an originating IP field or anything like that. So when you're in the single domain, the way to know who or what P advertised this route was pretty much based on the next hop. Obviously, you lose the next hop when you go across different border routers that are changing this field. Because of this lack of identification, basically that creates some issues in the EVPN procedures. And those procedures affected are per Ethernet segment mask withdraw for multi-homing, aliasing, backup path, AC influence TF election, and E3 egress filtering for bump traffic. So the draft was providing multiple options to solve this issue in the past. And basically the feedback that we got is that we really needed a single solution and we needed some guidance, some clear guidance. So basically what we are doing is to add a piece of information that we attach to the routes. And with that, basically we identify the routes and we can correlate the routes at the ingress PE. That new piece of information is what we call the egress PE identifier. It's a new sub-TLV in the BGP tunnel encapsulation attribute. In the draft, we described the structure. Basically, it has a reserved field, address family, and address field, where we encode a unique PE IP address. And the draft also follows Sue's draft about what type of information we need to include when we describe new sub-TLVs for the BGP tunnel encapsulation attribute. we tried to follow that as much as we could. So the procedures are basically simple, and they are illustrated on the diagram that you have on the right-hand side. So basically, when the egress Bs are advertising EVPN routes, they stamp this new egress B identifier with all the routes, the relevant routes. In this case, if we are talking about multi-homing and the mass withdrawal procedures, the egress P1 and P2, they advertise the AD routes and the MAC IP routes with the egress PID identifier. And now with that information, the ingress P, it doesn't matter that all the routes change the next hop along the way, but now we have a clear identification, and the ingress P can correlate the MAC IP routes with the AD various routes, and therefore they can apply the mass withdrawal procedure. And in a similar way, we would use the egress P identifier for other procedures, as described in the draft. We also added some information about what happens if on the egress P, you are missing the egress P identifier, if it is not present in the routes, and therefore you cannot correlate the routes based on that egress P identifier. So in that case, the ingress P will attempt to correlate the routes using the admin subfield of the route distinguisher of the routes. We also updated the security considerations because we are adding a new sub-TLV, and we had to say, okay, what happens with this new sub-TLV? And in the previous version, there was an option that we called the EVPN instance RD solution, and we moved that to an annex, because it's no longer part of the specification. All right, so after that, so now the document is pretty clear. It has a single solution. We think it has sufficient working group interest, and it's really ready for working group adoption. So we are requesting that.
Thank you. Any comment? Yes?
So that identifier address, do you require it to be routable?
It's a good question. I don't think we said anything about it in the draft. It doesn't really need to be routable because it's an identifier that you use to correlate routes.
Okay. The reason I ask is that in the type 4 route, there is a originating router's address, and there we explicitly say it does not need to be routable. And actually, I have some question regarding that, and it's for the similar problem. I think I'll follow up with you offline. Yeah.
Okay. It's a good point. Thank you.
Okay. I don't see any other questions, so we can move to the next presentation. Interesting. I don't see your slides in Meeteco. Okay. I got them on my laptop. Let me check. Manage slides. Does it work now? Interesting. Rejected file type. Okay. Do you mind that we move to the next presenter and I come back to it later when I fix it?
Yeah, sure.
Thank you.
Thank you.
So, Jeffrey, you are the next one.
So this is yet another proposal for improving the convergence in the case of EVP and multi-homing. We have 3 authors on this draft now. I'm presenting on behalf of them.
Yeah.
So let's look at the pictures here. If you look at the very first one, we have 2 leaf switches, L1, L2. They are the multi-homing Ps. The CE2 and CE1 are multi-home to those 2. So for each multi-home CE, there is a multi-home Ethernet segment there. On the MHES1, L1 is the DF. On the MHES2, L2 is the DF, designated forwarder. So the BOM traffic from L3 will be sent to both L1 and L2, but only the DF will forward the traffic. So in this case, L2 will not forward the traffic on any of the multi-home events. L2 will not forward to CE1, and L1 will not forward to CE2. Now, imagine that the link between the L2 and CE2 goes down. What expected is that L1 takes over, becomes a DF, and then traffic will be forwarded by L1 to both the Ethernet segments. So that's the DF-based bound forwarding. If you look at the third picture here, this time is bound traffic from a local attachment circuit on leaf 1. In this case, because it's local traffic, and also let's consider the VXLAN case, not the MPLS case, okay? So in this case, L1 will forward the local bound traffic to both CE1 and CE2, even though it is not a designated forwarder for the MHES2. And this is called local bias. The local traffic is always forwarded by the local PE. In the meantime, another copy is sent to the remote leaves. It's like L2. Now, L2, even though it is the DF for the MHES2, it will not forward the traffic because L2 knows that this traffic is from L1, and L1 has already forwarded the copy to CE2. So now, imagine that the link between L1 and CE2 goes down. Then L2 will forward the traffic to CE2 because L2 is the DF at MHES2. So that's the normal procedure for multi-homing, DF election, DF-based bound forwarding, and local bias-based forwarding in the case of VXLAN. So this procedure works, but they assume that the DF election and local bias states are updated very quickly. So for example, when the link goes down, the type 4 route is quickly withdrawn and quickly handled by the peers. Therefore, the DF election can happen quickly, and the For example, the BDF can quickly take over. And also in the case of local bias, the local bias state is updated quickly so that DF knows that the source key no longer has has a uplink to this segment, so it will start sending the bomb traffic. Also, similarly, in the case of a local bias, when the link comes up, the peers must also quickly detect it and update the local bias states. Here, the DF election is actually not an issue. You can always elect a new DF later because the existing DF can still do the job. But the local bias state needs to be updated. Otherwise, the existing DF will continue to forward the traffic, and the local PE who would receive the traffic locally also start forwarding the traffic, so you will get duplication. But that assumption is not always true, that you will get BGP EVPN routes originated and handled quickly. The delay could be due to the nature of the BGP update process. It could be due to the nature of the TCP connection. You could have delays because the TCP connection is typically between the routing engines, and then you also can flow control for TCP. So everything add together, they could delay this process. So with that delay, you could have traffic loss or traffic duplication. There is one way to address this. You use BFD to track the state of the links on the multi-home Ethernet segments, but that means that you have the per PE, Ethernet segment BSG sessions. That's a scaling concern. So the key to this solution is that we want to detect this link up and down of the remote PEs very quickly and handle it very quickly. So we're proposing a data plane-based notification and handling. So on the PE where the local link went down, the forwarding pass, the data plane can quickly send out UDP notifications to the peers very quickly. And you can send a few in a row just to compensate for the fact that you may lose those notifications. And then on the receiving side, you handle that right in your forwarding plane very quickly. This basically uses the router info notification mechanism that we have. We're trying to work on in the RTGW and also follow up maybe in the FANTEL working group if it forms. And also in the case of EVPN, there was a previous draft about doing dynamic overlay load balancing using those same kind of notifications. Here, we're just saying that even if you don't care about dynamic load balancing based on real-time node information, you can still use this for link up and down notification to speed up the convergence. I want to point out that this is independent of the normal control plane signaling, that it does not replace existing BGP-based solution. BGP-based EVPN route-based solution will just continue in its own pace. It may be delayed, but in the forwarding plane, your forwarding state could be updated quickly. The new DF could take over very quickly when the previous DF goes down, and your local bias state can be updated quickly once you know that a remote PE has gone down or coming up on this multi-home Ethernet segment. So far we have been talking about the notification between the peers on the multi-home segment. Optionally, this if you have a link down event on a multi-home Ethernet segment, you can send the notification to other PEs not on the segment as well. For example, if you have a single active multi-homing, the remote PEs can quickly switch to the backup PE. Also, even in the all-active multi-homing, the remote PEs can quickly update the load balancing to avoid the PEs with the downlink. This procedure is optional because even if you don't do this, you could rely on the egress protection to do the local repair while you're waiting for the global repair based on the BGP signaling. But I learned that some operators, they prefer not to use egress replication. So in that case, this could be used to improve the convergence. Again, it's just optional. And if you want to do it, the best would be using a multicast notification instead of sending the individual unicast notifications to every PE. Unless you have a small network, we don't have that many PEs, then sure, you can use unicast PEs to send the UDP notification. This is a basic description of this idea and the solution. It's 0.0 version. Here we're just seeking comments, suggestions. Based on the comments, we will refine the documents. And then when it's ready, we would like to seek adoption, but it's for later.
Jorge, go ahead.
Jorge Rabadan, Nokia. Yeah, thanks for the presentation, and I'll talk to you offline. But so one of the questions that I had when I read the document is, how do you, I didn't see anything about this, but how do you know where to send those notifications? Do you need to configure the remote PEs manually, or are you suggesting any sort of auto discovery or configuration? Or
so the type 4 routes still happen. We're not replacing those. So based on type 4 signal, you know your peers.
Right.
Yeah.
And in case you want to send them to the remote
same thing.
PEs,
yeah.
But the remote PEs that are not part of this Ethernet segment?
Those, I think you have other routes that you receive from remote PEs, right? They're MAC routes and they're type 1 routes, things like that.
Okay.
Yeah.
But I think you are also suggesting, in case of sending these notifications to the remote PEs, you're suggesting to use multicast, right? Which requires some infrastructure in the underlay.
Yes, if your underlay supports multicast, that's the best. You send one single copy of the notification. Every PE will get it as long as they subscribe to the multicast address. But if your infrastructure does not support multicast, then indeed you will have to use the unicast address, send it one by one. But as I mentioned earlier, that the entire procedure of sending the remote PEs is optional. So you either do it using the multicast address or using unicast address if you don't have that many PEs, or you just don't do it if it's a concern.
Okay, thanks. And my last comment would be, when I was going through the document, I thought, okay, the value of this is that allows you to relax the BGP timers that normally we are always tweaking for fast convergence, right? But if you have this sort of mechanism, you can rely on these data path-based notifications, and you can relax your BGP timers. But this doesn't help for node failures. So you still need to keep your timers tweaked anyway, right?
I'm having a little bit trouble hearing you clearly.
Oh.
So maybe we can talk offline.
Okay, we can do that. But the main point was this doesn't help for node failures.
No, not for node failure. It's actually for link failure, mainly for link failure. Yeah. If it's for node failure, then the BFD-based solution should work well.
Okay, thank you.
Yeah.
Any other comment? Thank you. Next speaker, Yao.
Hi, I'm Yao from Citi, and I'm presenting this draft on behalf of all the causes, and it is about data plane failure detection mechanisms for EVPN over SRv6. So the main purpose of this presentation is to seek feedback on the requirement and use cases. So as we know, for MPLS EVPN, RFC 9489 already defines mechanisms to detect data plane failures of MPLS EVPN. Using MPLS LCP ping. So the main procedures are the first echo request sent from the ingress PE to egress PE, and then egress PE validates the EVPN related information carried in the FEC subtier V, and the egress PE sends the results of the validation in an echo reply. So for SRv6 EVPN, there are already many implementations, and the requirement of data plane failure detection is similar with MPLS. So here we listed some use cases in the MPLS EVPN validation RFC. So for example, the unicast data plane check and BUM data plane check and so IP connectivity data plane check and etc. And they are they are also applicable for SRv6 EVPN validation. So about the options of the solution. So I think there are two basic principles. So first, it has to be IPv6 based. And the second is end-to-end validation mechanism is enough because you only need to validate this information on the egress PE. So the option one is the original option in the draft. It is ICMPv6 based, so you need new types of ICMPv6 messages, or using the or extending the existing ICMPv6 types. So the pros are the SRv6 already use the SRv6 OAM RFC already uses ICMPv6 request reply for data plane connectivity check. So extending ICMPv6 seems like a natural route. So the current is, so you need to define new packet formats, the structure, the subtier V like something. So the second option is UDP based. So as we know, MPLS echo request reply is UDP based. So we can use the same packet format as MPLS LSP PIM, but maybe a UDP port, so you can you can tell them apart. So the pros is, in this case, we can use many or most of the well-defined packet formats and procedures in MPLS. But the cons is that then you maybe not that IPv6 like, because you use this for EVPN validation, and in the meanwhile you use ICMPv6 for the normal data plane connectivity check. So whatever the solution is, the generic validation procedure is similar. So you send the validation request from the ingress PE. So you setting the SRv6 service set as the last segment in the set list of the SRH. Or the destination address in case of the SRv6 B scenario. And on the egress PE, when you're receiving the validation request, you validate, you find that the DA is locally or configured as a segment or local address, so you validated the related information, and then you send in the reply to the ingress PE. So this version 0.0.0 is first submitted in 2024, and we presented and discussed in BESS in IETF 120. So you can find a link below. And then in IETF 122, we presented the ICMPv6 based solution in 6 men. But the feedback is the first, you need to, a consensus is required on the use case or the requirement before discussing the detailed solution. And then we add several co-authors who are either interested in the topic or they have the really requirements to in the network. So a question to the working group is that we want to know what do you think about that we need data plan connectivity, data plan failure detection mechanisms in SRv6 VPN and eVPN scenario, just like what we have done for MPLS eVPN. So if you don't think so, you are also or have any other thoughts and welcome feedback and comments. So we just want to seek feedback so we can have some discussion, and then we can know how to progress this work. And that's all.
Krishna, go ahead.
Krishna Swami, Cisco. Is these probes are sent proactively?
Excuse me, could you?
Yeah. Is these probes are sent proactively or on some failure?
So is the reply yes? So it's the basic mechanism you want to detect. So so if you have some failure, then you have a return code. So if the things you want to validate didn't exist or not the same as a request, so you have a return code just like MPLS SPP.
I see.
Yeah.
Okay, thanks.
Thank you.
Thank you. Any other comment? No. Okay, let's move to
next is also mine. So it is not a BESS draft, but we're using this in the BGP VPN scenario, and we are referring something or the fields defined in BESS. So we put it here to seek some feedback comments. So some background information about IPFix. It is a sort of IP flow information export protocol and serves as a means to transmitting the traffic flow information over the network from an exporter to a collector. So normally you use it when you're monitoring the traffic flow in the network. Then you using the IPFix message to send the information of the traffic flow. For example, what are the fields of the packet and what's the forwarding status or some statistics information of the flow. So the important part of the IPFix is the information element. So it is a description of an attribute that may appear in the IPFix record. So when monitoring traffic flows on the ingress E in a network with BGP VPN deployed, so we want to know which egress fee is the flow forwarded to. There are existing IPFix information elements related, but they are not enough. So the information element, BGP next hop, IPv4 address or IPv6 address define the IP address of the next adjacent BGP hop. But if there are more than one type of BGP route used in the network, for example, BGP VPN is used together with BGP LU. So it is not clear what type of the BGP route the existing information element is carrying. So in this draft, we define new information element to carry the egress P information in IPv6. So the first part is we define two generic information elements to obtain egress P info. So the first is BGP VPN next hop IPv4 address, and the next is for V6 address. So they can be used to carry the next hop address of the BGP VPN route. So of course it has some limitations because if you use it in the multi-AS backbones, so the address of the final egress PE cannot be obtained. So you may only get the ASBR address, but it seems it has to be, it is. So for SRv6 VPN, because we want to use this both in the in the MPLS VPN and SRv6 VPN network. So another choice is to export the locator information of the SRv6 service set, because normally the locator of the SRv6 service set is well defined on each egress P. So, so using the new information element, so SRv6 service set and together with SRv6 locator length. So when using them together, you can get the locator information. Yeah, that's all. That welcome review, feedback, and comments and collaboration. So we define this VPN related information elements properly. So anything else that needs to be taken into consideration, or any other options we can do to get egress information. So that's all.
Okay, well, one quick question, speaking as an individual. So I see the problems that you are trying to solve, but if you think, for instance, about the basic case where you have just a BGP VPN route and the regular next up, no BGP LU at all, do you expect an implementation to fill both fields, so the regular IP next up and the VPN next up? Because I see what you want to do, but I'm just wondering if it's creating even more complexity and sometimes confusion, I would say.
So you mean if we use the BGP VPN next hop and if they appear together with the existing BGP next hop address? So
I missed your point. Can you say it again?
So is your question is that how we use the existing information element, so the BGP next hop IP address and the new defined BGP VPN next hop IP address together? Yeah, so this draft will be presenting OPSAWG this afternoon as well, because we have some question about the existing BGP next hop IP address information. We really don't know how to use it because we don't know what it represents now. Maybe different vendors are using it differently. So maybe.
Yeah, but you need to provide some guidance on how the vendor should fill up the information. Otherwise, honestly, you can just create confusion because you may have one implementation filling one field, one implementation filling another field. And yeah, how do you want, I would say, the application to deal with that?
Okay. Oh, thank you for your comments. Where we think about it.
Thank you.
Thank you.
Jorge, do you want to come back? I think we probably solved your slide issue. Yeah, wonderful.
Oh, great.
Thank you, Miteko, guys.
Yeah. Thank you, and sorry for the hassle. I don't know what was wrong with the PowerPoint. Okay, the Anycast aliasing draft. We published version 5. We requested a working group adoption like last time, but we wanted to share the latest changes because we think they are significant. So, quick recap. This is about supporting or modifying the existing EVPN multi-homing solution to use Anycast VTEPs. Anycast VTEP is an IP address that is used in the VXLAN header and is shared by all the Ps or leaves attached to the same Ethernet segment or groups of Ethernet segments. The idea is that when the egress leaves that are attached to the Ethernet segments, they advertise the 80 per ES routes. They attach this Anycast VTEP so that the ingress leaves, like in this case in the diagram, leaf 3, can create an ES destination using this Anycast VTEP. And then is really the underlay, the one in charge of doing the load balancing or finding, ECMP towards this Anycast VTEP. So the benefits of this draft are basically we suppress the 80 per EVI routes and we improve convergence when you have failures in the underlay or even in the overlay. And this works for layer 2 broadcast domains, but also for layer 3. You can use this for multi-home subnets as well. So the changes that we made in revision 5 are the ones you have in the slide. In section 2, we made some clarifications about when to use the new BGP extensions. We also clarified that the BGP encapsulation extended community is still advertised when you add the Anycast VTEP to the routes. In section 3, talking about the procedures, we improved the error handling procedures and the description. In the section 5.1 that talks about Anycast multi-homing for multi-home IP prefixes, also we clarified that all the egress PEs that are attached to the multi-home subnet or prefix, they need to advertise the IP prefix routes with the same router's MAC. And last but not least, we added a new section talking about the applicability of Anycast multi-homing to inter-domain service gateways. And this is probably the main change that we really want you to look at. And talking a little bit more about this, what we mean by that is this Anycast multi-homing extensions that we were talking about for leaf routers, you can also use them in the gateway PEs. And in the example we have in the diagram, for instance, you have 2 gateway PEs that are interconnecting to EVPN domains following the RFC 9014 procedures. So on those PEs, if you follow the 9014, those would be attached to an interconnect Ethernet segment that basically represents the redundancy of the domain when connecting to the other domain. So for that interconnect Ethernet segment, you can apply exactly the same procedures. You can advertise the Anycast VTEP along with the 80 per ES routes. You can suppress the 80 per EVI routes, and you can use the Anycast VTEP to have the ECMP working at the underlay as opposed to in the overlay. And it's not represented in the diagram, but you can also use that for layer 3 when you have layer 3 domains and you are interconnecting them. And that would be a small extension to the EVPN IP VPN interworking draft, where you can actually re-advertise or re-originate the IP prefix routes with this Anycast VTEP as well, right? So the document also talks about what happens when you are interconnecting to the 2 domains, but only one of them supports Anycast multi-homing. The reason why might be because suppose EVPN domain 1 is VXLAN based, so it does support this extension, but EVPN domain 2 is MPLS based, right? And then this draft or this extension is really for IP tunnels and not really for MPLS. Okay, so with that, please have a look at that section and provide feedback. And I saw that the draft is already on the queue for working group adoption, so hopefully we'll get to it.
Krishna?
Yeah. Thanks, Ore, for adding the 9014 with the Anycast next stop. So just needed one clarification. Can you go back to the previous slide? Yeah. So on the gateways, if they have a local attachments, so now the local attachments will have their respective ether segments. So is being clarified in the draft?
Yeah, in the sense that the current solution, even for the leaves, it supports already local attachment circuits that are not multi-home, right? And for instance, this doesn't change the procedures for BOM traffic, meaning that the two gateway PEs, they will still send the IMET routes with different next hops. So the leaf PEs will send BOM traffic to both, and one of them will block the, depending who the DF is, will block the traffic and all that. And for single home local attachment circuits, the MAC routes are advertised normally. So, those hosts will be reached normally. There are no changes there.
Okay. Sure. And with the IP multi-homing, so since there is no EAD, ES route, so the Anycast next stop is carried in the NLRI?
So same as the existing procedures for the leaf routers. So it's really, when you have a multi-home subnet or prefixes, you advertise the Anycast VTEP along with the IP prefix routes. So in a
that
nutshell,
goes in an NLRI then?
Yeah, for multi-home prefixes, you advertise it with the route I5s. For the rest of the procedures for multi-homing, you advertise it with the AD per ES routes.
Okay, thanks.
Thank you.
Any other comment? Thank you.
Thank you.
Good morning, Mankamna Mishra from Cisco Systems. So I'll be presenting a draft for signaling alternative labels for BGP prefixes. Just to give a quick history, I did present a problem statement a year ago in IDR, and it was just outlining what is the problem and what is the problem and what are possible solutions, and we can, so that we could pick one among multiple. So just to kind of go back to the problem statement, because we're presenting this in BESS first time. So we have a label allocation mode, and some of them are per prefix, per WRF, or per next hop received label. Depending on deployment, depending on scale, I think any of them can be used. But we are going to talk about the problem which comes with per next hop received label. Let's consider a case where you have a border router, and to support a symmetric pick, you have a BGP peering between both of them. So, and we are going to use per next hop receive label as a label allocation mode. So in this case, if PE1 starts sending some of the prefixes to border router 1 and 2, both of them initially are going to allocate a local label. And these local label will be advertised towards PE2, which is the remote side. And there is a next hop self here. And what they're going to do, border router 1 and 2, both of them also going to exchange the same route towards each other. So at this point of time, border router 1 sees PE1 as a best path and BR2 as a backup path. And same thing will be done in BR2 as well. At the next step, as we said that the label allocation mode is per next hop plus label as a key, what is going to happen at border router 1? So border router 1 receives an update from router 2 where it has given its label plus next hop as itself. So it is going to allocate one more label and it is going to send update towards PE2 and border router 2. And same process will happen at border router 2 as well. And this keeps continuing because of the logic of having next hop and label as a key. So there will be label churn happening here and it will keep going on. This was the problem which we discussed, and we were having a discussion about what would be the best way. So we know that there is a problem, there is a extra context needed so that you can avoid this loop from happening. And there were few choices which we discussed last time during IDR meeting and even offline. One of them was NHC attribute and another one was extended community. Though both of them have their own pros and cons, and we can definitely argue one over other, but based on the input which we got from the list and some of the other vendors, and the work which is going on right now in IDR with respect to the attribute. So NHC is the direction we have decided to take. And currently this draft is going to talk about the solution based on NHC, which is next hop attribute. So in this case, what we are going to do, we are going to introduce a alternate label for BGP prefixes, and these will be advertised along with primary label. The draft does provide a mechanism where potentially you can have one or more alternative labels depending on what type of use case you want to really support. And these labels are going to represent different context, and local policy or implementation can decide how exactly you want to determine the action based on these alternate labels. The signaling it is going to happen is with next hop dependent characteristic. So your NLRI will carry a primary MPLS label, and then we have NHC attribute, which will have potentially one or more alternative label. Though there was a debate or rather discussion between among some of the engineers that should we have just one label or should we have provision for multiple label. Currently, even though the draft talks about you can have multiple labels, I think it will be good to discuss in working group that if we want to keep it open with multiple labels or we want to really restrict only one label. If we go back to the problem statements picture again, so what is going to happen now? So in this case, we receive a label, what we received earlier, and both border router, they are going to allocate initial label. And the context is PE1 label. So my next hop is PE1 and label which I received was 100. On the border router 2, same context is going to be used. So the first step, we allocate a label and we send the update to PE2 and each border router are sending update to each other. At the next step with this proposal, what will happen now, border router 1 receives an update from border router 2 with its own local label. So it is going to now allocate one more label, and while sending an update, it is going to provide as a next hop attribute the label 200, which was allocated earlier. So basically, border router 2 not only gets the latest updated label, at the same time it carries the previous label as well. So at step 2, we are going to allocate once more new label and we are going to advertise towards each other in the border router and towards the remote side and the PE2. Okay, so at step 3, if you go here now, border router 1 does see update coming from border router 2 where the next hop label has changed to 301, but it also carries the previous, so 301 will be as a part of NLRI primary label, whereas your characteristic attribute carries the label 300. So what it is going to see that the previous context, I already have a label allocated where border router 2 with label 300. So it is going to stop allocating any more local labels. So basically, at first and second step, you are going to only allocate 2 labels, which will be, one of them will be primary and one of them which you can use it for a backup. And there will be only 2 update which will be going towards PE2. So this prevents the loop and no more local label allocation will happen what was happening originally. The forwarding model, Ingress PE can choose to have forwarding between primary label or alternate label, and it can be driven by a policy or different traffic type. I think it is completely in the hand of implementation plus the operator, that how exactly they want to use these labels. As of now, draft doesn't mandate that which label will be used for which purpose. Some of the example use case, and maybe there are more use cases also which can be covered, which we may not have been able to document here, is fast reroute, then backup path, some of the traffic engineering, and for again, as a part of traffic engineering, different label can represent different SR path in case you're using SR. And then to differentiate between different services and services classes. Some of the benefits which we think is you have now more operational advantage with respect to having a different behavior, and then it definitely avoids that loop. And the reason why we were going using NHC is leveraging existing BGP extensibility. So one of the reason was definitely there are rules which is already being defined for NHC and it can be reused here. And with respect to deployment also, it can be incrementally rolled out. And I think backward compatibility is also being taken care in this draft. So the next step is please provide any input here. And I think we can have more discussion in the list as well.
Jorge Rodan, Nokia. Thanks for the presentation. I went through the draft. I saw a reference that you could use this for labeled unicast families and VPN IP families, but I didn't see any reference to EVPN family. Any reason why that is excluded? Because I guess the same problem applies, right?
Thanks for comment. I think maybe we can definitely add it. So there was no specific reason to exclude EVPN.
Okay, thank you.
Any other comment? No. So let me check, but I think we are done with our agenda. So thank you for joining and enjoy the rest of the week.